Hi, I'm Lauren Helfer from Leaf and STEM Learning. I'm here today to help you with a new strategy called Numberless Word Problems. Let's get started. So you may be asking, what are numberless word problems? Numberless word problems are a systematic way to help your students break their bad habits that they've developed around the concept of problem solving. So one of the first things that we're using numberless word problems to do is to help our students build better reading habits in the math classroom. So when your students take tests or when they're solving problems, you may look at their work afterwards and think to yourself, they just didn't read the question, or they're great at the computations, but whenever we try to do problem solving, whenever we use a word problem, they just seem to struggle. So this strategy is going to help you get your students to be better close readers on the types of reading that we're going to do frequently in math class, which is usually story problems. One of the other things that numberless word problems are going to help you with is to help your students eliminate the use of their ineffective strategies. So students come to us with all different types of strategies from their previous grades. So some of the strategies are great, but some of the strategies may have made some really bad habits. So some students do things like look for keywords. And keywords, especially in the younger grades, can be somewhat effective, but by the time they get to 5th grade, 6th grade, these upper elementary, lower junior high type math classes, these keywords can actually hurt them because a lot of times the keywords are used in a way to be intentionally tricky to make sure that the students are understanding the question and not just relying on keywords. So for example, some students, whenever they read a problem, if they see the word total, their first thinking is, I'm going to add everything in this problem. No matter what else it says, I'm just going to take all the numbers and add them up because it says total. Well, as educators, as grown-ups, we know that a total doesn't just mean, well, let's add everything up. A total could be the answer to a multiplication problem. The word total could actually be used in addition and subtraction problems. The word total can just be a normal word in the problem-solving process, just as part of the story, and not necessarily be a keyword for anything. So we want our students to decide how they're going to solve a problem based on the actual problem scenario and their understanding of reading the story problem and not on looking for keywords. Another common one that my students often had trouble with was when they saw the word difference. When they saw the word difference, they automatically thought they were supposed to subtract. Well, difference could just mean that there is a difference between two things in the problem, that they are not the same, they are somehow different. It doesn't necessarily mean that we need to subtract. For example, if we already know the difference, it might actually be an addition problem. Or it could just be saying that two items in the story are different from each other and not have anything to do with subtraction at all. So we really need to break those bad keyword habits that our students might have developed in previous grades. Another thing that we're trying to do is we're trying to get our students to think more about math as in terms of mathematical models, and in terms of having good math conversations, and in terms of better reasoning, mathematical reasoning. And when we do this, we're basically making that cycle of, oh, I read the word problem, I'm picking an operation, now I'm solving. We're slowing that cycle down and giving them time to think. So we really want our students, when they are solving, especially complex story problem type math questions, we want them to fully understand the question. We want them to make models of that question using strip diagrams or bar diagrams, depending on what you call them. And we want our students to have conversations and be able to defend their reasoning about why they're doing what they're doing and the answers that they're getting. So many times students will solve a problem and get an answer that is completely unreasonable, but they have no idea that it's not reasonable because they haven't taken the time to understand the problem. I think of a specific example back from my classroom. We had a question and it was about how many hours would someone work on a job. And it was talking about in one day. How many hours would they work on that job in one day? Well, some of the answers that the kids were getting were in the hundreds. And that didn't make any sense. Well, if it's a job they're doing in one day, it has to be 24 hours or less. So the students weren't recognizing that their answer of hundreds of hours of work in a day was not a reasonable solution. When once we slowed down and I said, wait a second, it's talking about what she's doing in one day, right? Okay. Well, a day is how many hours? They said, 24. Okay, so if a day is 24 hours, look at your answers. Could she have done that amount of work today? They looked at it. First, they sort of didn't understand what I was saying, and then they were like, oh. And they knew that their answer was completely unreasonable at that point, but they hadn't slowed down to think about what was happening. They hadn't slowed down to think before they started solving that their answer needed to be an amount of hours that could actually happen in one day. So we want our students to slow down, to break that cycle of bad, ineffective strategies, and to develop strategies based around good reading habits for story problems. So many of our students don't bring strategies between their classes. They compartmentalize. In math, we do this, and in reading class, we do this, and in science class, we're going to do this, and they don't bring those strategies together. So what we need to do as math teachers is we need to make sure our students are still using effective reading strategies. That's really the most important thing. What I always talk to my students about is that we're going to think about story problems like the books that we read in language arts class. They're just really short and usually pretty boring stories. But just like the stories that we read in language arts class, they have a beginning and a middle and an end. And if we can understand the story that's happening in the problem, we're going to be much more likely to choose the correct operations and do the correct calculations and solve the problem in the end more efficiently, because we're not having to go back and do our work over and over when we're picking ineffective strategies to try to use for problem solving. So now let's look at what these numberless word problems, what they are not. So numberless word problems are not a quick fix strategy. I know we would love to be able to have something like a magic wand and we wave it and our students are automatically better problem solvers. But unfortunately, that's not a, if there was, we would all do it and then we'd be done and our kids would be great mathematicians and we wouldn't have to worry about it anymore. So you're not going to do one question set of numberless word problems and then your students are cured of their crazy strategies that they have been trying to do when they're problem solving in their classroom. So you're going to need to do some repetition with this. You're going to need to work on this over a period of time, doing different types of numberless word problems in different scenarios and in over a period of time. You've got enough numberless word problems in this set with your 70 sets of problems to have plenty for 2 or 3 months, even if you don't make a single one on your own. They're also, I would not, at least not at the beginning, use numberless word problems as a math station. So they look kind of like task cards, especially the printable ones, but especially at the beginning, I would avoid that temptation to take your numberless word problems and just put them into a math station. And this is the reasoning for that. Um, if you do that and the kids haven't started breaking those bad habits with you and you're coaching along the way of, well, let's look at it like this. Let's look at just this step. They're going to flip straight through step 1, 2, and 3 to that last step where they can see the entire problem. And they're just going to go back to those old strategies that aren't ineffective, and they're not going to be using any of the good stuff that numberless word problems teach. They're just going to solve the last step using their same ineffective strategies, and it's not going to help your students grow. Also, numberless word problems, they're not a question bank or test prep. So it's tempting when we have a large set of great rigorous questions that we want to use them for our test prep or for question bank for our own tests. And I would, caution you not to do that because they're not test style questions. They're open-ended. Some of them are a bit more complicated than you would find in a typical test type story problem, just because we're trying to take our students to the top problem solving ability. We're trying to bring them way up here. We're not trying to get them just adequate. We're trying to get them truly proficient and fluent in problem solving. And if you scrap the set 1, 2, and if you scrap 1, 2, and 3 and just use that fourth one, you're missing out on 3/4 of the awesomeness that is in the numberless word problem set. So I would resist that temptation and try to use them as they're intended. They're also, unlike some of the really cute posters you can get about keywords, like this cute poster means all these words mean multiply, and this poster, all these words mean divide, and you're not getting a cute poster to hang up on your wall. Now, you're getting something much better than a poster. You're getting students with numberless word problem understanding, and you're getting them developing better problem solving habits, but it's not going to be cute. It's going to be hard work, and it's going to be rigorous, and it's not going to be something you're just going to put up on your wall and say, look over there at our anchor chart. It looks cute. Let's go. But you can, of course, you're going to end up with some great anchor charts of your students thinking on the specific problems, which those you could hang up on their wall. They may not be super cute, but they'll be very informative on your students' thinking process and help them remember how to stop and slow down and reason through problems instead of just looking for keywords. So now we're getting into the good stuff. We're going to talk about how do you actually write your own numberless word problem series. So we're going to start with a normal word problem, just like the regular type. So we got this example over here. So we're going to use this question to make a numberless word problem. So our regular problem says, a baby bird weighed 28.2 ounces. As the baby bird gets older, it gains weight. By the time it learns to fly, the bird weighs 42.05 ounces. How much weight did the bird gain? So we're going to take the idea of our regular problem and crop it down into the step 1 of a numberless word problem question series. So the first thing to know about a question series for numberless word problems is that there's typically 4 parts in the question series, and in each part, just 1 or sometimes 2 pieces of information are added back into the question. So we're going to now take our regular problem and we're going to turn it numberless. So our first step is easy. We're just going to remove the question. So we're taking out the question. So the question's gone. So in part one, we do not have a question as a part of the story problem. And then, of course, since it's numberless, the question will have no numbers. So we're going to use relative value words like a few or some rather than blanks or variables. So in this case, we're going to change it to a baby bird weighed just a few ounces. As the baby bird gets older, it gains weight. By the time it learns to fly, the bird weighs more. So you see that it's just like a little story now. It has a beginning, a middle, and an end. At the beginning, it weighed few ounces. And then in the middle, it gets older and gains weight. And at the end, it learns to fly and it weighs more than it did at the beginning. So it's a super short, little bit boring story, but it is a story. It has a beginning, a middle, and an end. So you may be wondering why I said no blanks in the word problem. So I have that same word problem. Well, what if instead of replacing the numbers with relative size words, I actually just left blanks? So in this case, we would have a baby bird weighed blank ounces. As the baby bird gets older, it gains weight. By the time it learns to fly, the bird weighs blank ounces. And we have two reasons why we're not going to do that. So reason number one, blanks allow the student to see where the numbers are going to be. With the blanks in place, students will start mentally putting numbers there, even if they're not the same numbers that you're going to use in the final problem. And this will lead students right back into the same old habits of choosing operations and choosing strategies before they actually understand the problem. It also becomes immediately obvious looking at this problem where the value is not, where we're going to have that unknown, where when we did not have blanks, there were three different values that until they got added could have possibly been the unknown. So we don't want to give that much away in step one because that's going to lead our students to do some of those same old bad habits. It's not going to be as effective in retraining them to think about story problems as stories and not just as a math question. And reason number two is, since we're trying to build good reading habits for our students, blanks in the middle of a paragraph make it so that we're not really reading fluently anymore. When I read it to you earlier, the blank when I was speaking, when I was reading that out loud, did not help build our understanding of the scenario. It sort of breaks in there and makes it less easy to understand what the story is actually about. And that's what we're wanting our students to do, is to understand the story. And when we add these crazy blanks in there, that doesn't look like a story. It doesn't read like a story. It reads like a word problem. It reads like a math problem. And we don't want it to do that. We want it to read like a story. So no blanks. So now we're on to part two. And we're going to add in just one value back into the question, and we want to be strategic about which number we add back in. So we're just working on one problem right now, but if you were writing several sets of question series, you don't always want to add in the same number each time. So that way your students get used to it and they're always like, oh, well, on part two, she's going to add in the first number. We want to keep it random for our students about what we're adding back in. Also, sometimes waiting to hold back certain pieces of information cause different types of thinking than presenting that information right away in step 2. So here we have a baby bird weighed just a few ounces. Let's add back in one of the numbers. So we added back in the number at the end. So now it says the baby bird weighed just a few ounces. As the baby bird gets older, it gains weight. By the time it learns to fly, the bird weighs 42.05 ounces. As you can see, there's nothing that we can solve right now because we don't know yet. Well, are we going to find out maybe how much weight he gains? Are we going to find out how much weight the bird was when the question started? We don't know. So in part 3, you're going to add in one more value. If your problem is a one-step question like this one, this will be your last number. If your problem is a multi-step question, you may still have to add in more numbers either in part 3 or later even in part 4, and we'll talk about how to do that in just a few minutes. So let's add in another value. Excuse me. So now both of our numbers are back in there. A baby bird weighed just 28.2 ounces. As the baby bird gets older, it gains weight. By the time it learns to fly, the bird weighs 42.05 ounces. So now we can have conversations with our students about, well, what do you think it's going to ask? In this case, there's not too many different things that it could ask, but it's good for your students to maybe make their own wording about how it might be asked in this question. For example, the question might ask, how much weight did the baby bird gain? Or it might ask, what was the difference between the baby bird's weight at the beginning and the end of the story? Two different questions, but with the same solution, but your students will see that question by coming up with it themselves and thinking about that. They'll see all those different ways that it could be asked. So in part 4, okay, so let's talk a little bit more about part 3. So on a multi-step problem, you'll have a couple of choices. So this one was only a one-step problem, but sometimes you'll have questions with 2 or 3 steps because multi-step problems are probably one of the hardest things for kids this age to grasp. So you're going to be using your numberless word problems a lot for developing good problem-solving strategies in multi-step problem-solving situations. So one of the things you can do is you can add in more than one value on step 3. So if we had other values that we needed to add in, instead of just adding 28.2, we could have also added some additional values. You can add in a value when you get to step 4, which we'll get to in just a minute. You can also add a value as a part of the question on step 4. We'll talk about that more and how that might look. You could make more than 4 steps. This isn't one of my favorites because the problem-solving process that you're going to be doing when you're doing numberless word problems, it does take a little while. And the more steps you add in, the longer you're going to make this process take, and you might not be able to hold your students' attention and engagement for more than 4 steps. So 4 steps is usually where I like to leave it. I don't like to go more than 4. Or you could combine several of these if you have a question with a lot of steps or a lot of numbers, even if it doesn't have too many steps, where you can maybe add in an extra value on step 3 and then also add in a value in the question to get all those numbers added in before you reach the end of the problem. So now we're on to part 4. So on this question, all that we have left is to add back in the question that we want our students to solve. If we have a multi-step problem, we may be adding in more values at this point, but for us, In this question, we're just going to add that question back in at the bottom. So now we have a complete word problem. It looks just like a normal word problem at this point. But by the time we've got into this, we've done so much thinking and so much problem solving analysis about this question that our students are going to be ready to solve the problem. They're going to know what to do. They're going to at least have some really great ideas on what they want to do and what they need to do to solve the problem effectively. So let's talk about another type of numberless word problem, one with variables. And in this example, it's going to be a multi-step problem. So we're going to see some of those ways that you can add back in some of those extra values that we talked about in our last question set. So you may be wondering, well, you told me I can't use any blanks. That's not an effective numberless word problem. So can I write a question with variables? Well, yes, you can. You can write almost any type of word problem as a numberless word problem, but you're going to treat the variables as you would a numeral, as a number. You're not going to treat them as a blank or our relative words. We're going to treat them the same way, the same exact way we would treat it if it was actually a number, because in the word problem, a variable is a value, it's a number. So we're not going to put variables in during part one. So here we have a part one style question. So let's go ahead and look at that. It says there are offices on each floor of a building. There are some on the first floor. On all the other floors, there are more offices. So we can see here that we have this very short story. It has a beginning, a middle, and an end. It's really a very boring story because there's not anyone like doing any interesting stuff. There's not even a baby bird that's growing. It's just an office building. But at the beginning, we know that this is an office building, and there are offices on each floor. In the middle, we learn that there are some offices on the first floor, and that on all the other floors, there are more offices. So we have this really short story about the way an office building is set up. So when we move to step 2, we're going to add in a value. And in this case, you can see that the value we added in wasn't a number, it was a variable, the variable x. So now we know there are offices on each floor of a building. There are some on the first floor. On all the other floors, there are x offices. Okay, so we still can't solve anything and we still don't have any actual numbers, but we do have a value. I know now that on all the floors except for the first floor, there are x offices. At this point, you could talk with your students like, what do you think x could be? What values would be reasonable for x? Could x be 0? Well, no, because there have to be offices on the other floors of the building, according to the question. Could x be 5 million? Well, no, because that would be way too big for an office building. An office building couldn't have 5 million offices on a floor. That would not be reasonable. Now we're on to part 3. So now we're going to add in some more values. In this case, because the problem is multi-step, you can see I'm going to add in 2 values on part 3 instead of just 1. So now our problems is that there are offices on each floor of a building. There are 5 offices on the first floor. On all the other 7 floors, there are X offices. So now we know how tall the building is. It has a first floor and then 7 other floors. So we have an 8-story building, and there's X offices on all the floors except for the first floor, where there are 5 offices. So the only thing we're missing now is the question. And in this problem, there could be lots of different types of questions. Unlike our other one where whatever question we were asking, it was probably going to be pretty much the same thing that we were going to be finding an answer for. In this case, there's a lot of different questions we could ask. So when we're thinking about those questions and the students are trying to predict what is this problem going to ask us, these are some ideas of types of things that we might be asked. So we could be asked something like, well, what expression represents the number of offices in the building? In that case, they wouldn't actually be solving for a value. They'd be finding an expression that represents the story. They could draw a strip diagram that represents the building if it had a total of 68 offices. So in that case, we're given another number in our question, and we're going to use that number to find a solution. And then we have another question. If X is 14, how many offices are in the building? So in that case, totally different type of problem than the other two. It turns into a more standard type of problem, but where they're going to have to substitute a value in for that variable, which can be a tricky skill for some students if they aren't thinking in that mindset. But at this point, they will have done a lot of work already in thinking about what this office building actually looks like. What does this scenario actually mean? So when they come time to solve this multi-step problem, they're going to be more prepared than if they had just received this multi-step problem in the traditional format. So now you're going to try writing a numberless word problem on your own. So in your course, you have this step-by-step guide called the Numberless Word Problem Writing Quick Guide, and it has some of the key ideas for each step that you're looking to do when you're writing your word problem, and a place for you to fill in the blanks to make writing your own word problems easier. So make sure you go grab this download so that you can start writing your own. This can also help you if you want to edit some of the questions that you already have, that you can look and see, well, how do I want to change this? And this will help you to remember sort of at which step you're wanting to add in which types of information and help you plan your questions for your students.